This video we're going to look at binary. Binary is a number system. Now we currently use a decimal number system, so our number system is based around the number 10. So that's what the decimal system is. So DEC, if decimal, stands for 10. Binary, BI, stands for 2. So we learn in primary school about place value. So we've got units, we've got tens, we've got hundreds, and so on. So we've got all powers of tens. So 10 to the power of 0, as we'll see later on when we look at our indices, 10 to the power of 0 just means 1, 10 to the power of 1 is 10, 10 to the power of 2 is 100, and so on and so on and so on. So each place value column, there are 10 possible digit values from 0 to 9. What we're going to look at today is the binary system. So the binary system is based around the number 2, where each place value heading is a power of 2. So the first one is 2 to the power of 0, which is 1. The next one is 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. 2 to the power of 3, which would be 8. 2 to the power of 4, which would be 16, etc., etc., etc. So we're going to look at how we can express numbers, write numbers, decimal numbers in binary form. So this says writing decimal numbers in binary. Express a number as a sum of the powers of 2. So 1, 2, 4, 8, 16, 32, 64, 128, etc. It is well worth your while to learn off that these are the powers of 2. Remember how you get from one of them to the next one. The first one is 1, then times 2 to give you 2, times 2 to give you 4, times 2 to give you 8, times 2 to give you 16, times 2 to give you 32, times 2 to give you 64, times 2 to give you 128. Okay, we're going to look at an example of how we actually do this. So this example says, for example, we're doing 25. So how you would do 25, work it out. The biggest power of 2 that goes into 25 is 16. The next one then that fits in would be 8. That's because 16 plus 8 gives you 24. And then you have to add on 1. Now, what we'll do then, so we know 16 is the biggest one we're going to use. So you put down all the powers of 2. So we've got 16, and then 8 is the next one, and then 4 is the next one, then 2, and then 1. And underneath that then, 16 we wanted, so we put a 1. So basically 1 represents it's switched on, a 0 represents it's switched off. So we had 16, so that's why there's a 1. There's an 8 here, so that's why there's a 1 here underneath the 8. The next number is a 1, so that means our 4 is switched off, so that's why it's a 0. Our 2 is switched off, that's why it's a 0. And our 1 is switched on, that's why it's a 1. So 25 written in binary form is 10001, and you can see that's what we have here, 11001, and that's what we have here, we have 11001. So we're going to do a couple of examples using the same method. Okay, first one we're looking at here is we've been asked to do 30. Now the biggest power that goes into 30 is, the biggest power of 2 that will go into 30 is 16. And then 8 would go in, and 16 plus 8 takes us up to 24. We can add another 4, which would take us up to 28. And we could add another 2, and that is it. So 30 is equal to 16 plus 8 plus 4 plus 2. Okay, we're going to write that out then. We have 16, 8, 4, 2, and 1. But we do not want the 16, so we just want 1. Sorry, we do want the 16, we do want the 8, we do want the 4, we do want the 2, but we do not want the 1. So that's what 30 is equal to in binary. Same idea for this one. The biggest power that will go in of 2, which will go into 56, will be 32. And then we could have the 16. So that takes us up to 48. We could also have the 8, and that would take us up to 56, and that's all. So that's us bang on the 56. So we're just going to write that out again. We write that out again. What we will have then, we're allowed our 32, we're allowed our 16, we're allowed our 8, and we're not allowed the 4. Remember, we're not allowed the 2, we're not allowed the 1. So you're allowed the 16, you're allowed the sorry, you're allowed to 32, you're allowed to 16, you're allowed to 8, not allowed to 4, not allowed to 2, not allowed to 1. So that's what 56 looks like in binary. Okay, next one, we've got 100. So 100, 64 will go into it. 32 would go into it. That takes us up to 96. So we need to add on a 4 just. So just 4. So we'll write all of the numbers in. So we've got 64, 32, 16, 8, 4, 2, and 1. And we're allowed 64, we're allowed 32, not allowed to 16, not allowed to 8, we're allowed to 4, not allowed to 2, not allowed to 1. So we'll just write that out when I get that out again nicely. We'll just say that means 100 is equal to, in binary, 1100 100. We're going to look now at how we write binary numbers as decimals. We're going to jump to the example here. So in this example, it says we're going to write how we write 10, 10, 10, 10. So if you count up the number of things we've got 1, 2, 3, 4, 5, 6. So we've written down, we can get rid of the 64, we don't actually need it. We've got 6 things written down. So starting with the 1, so start 1, 2, 4, 8, 16, and 32. There's your 6 things. Now look where the 1s are on, then it's switched on. So that means we take the 32, it's switched on. We take the 8, because it's switched on. We take the 2, it's switched on. And the rest are switched off. So that means 32 plus 8 plus 2 works out to be 42. So you can see that 1, 0, 1, 0, 1, 0 is going to be equal to 42. Okay, so we're going to do a couple of first sales. It says change the following binary numbers into decimal numbers. So the first one we've got is 1, 1, 1, 0, 1. So I'm going to starting with this 1, so which represents 1, and then we've got another digit here, so that would represent 2, another digit here would represent 4, another digit here would represent 8, another digit here would represent 16. Now let's write down underneath it, it has binary again, 1, 1, 1, 0, 1. So that tells you 16, it's got a 1 underneath it, so it's switched on, 8 has got a 1 underneath it, it's switched on, 4 has got a 1 underneath it, it's switched on, and the 1 is also switched on. So you just add those all up, and the easy way to add that up, we've got 16 and a 4 work together to give you 20, and then you've got 8 and a 1, which is going to give you 29. Next one, again I'm starting with this to get my place value. That's going to be represent the 1s, the next one in would represent 2, the next one in would represent 4, the next one in would represent 8, the next one would represent 16, and the last one would represent 32. Now let's write our binary number underneath it and see which ones are actually switched on, which are switched off. So 32 is clearly switched on, the 2 is switched on, and the 1 is switched on. 32 plus 2 is 34, plus another 1 is 35. And our last one, again, I'm starting with this, so that's going to be 1, the next digit's going to be 2, the next digit in is going to be, next digit in is going to be 4, next digit, so we've got the here, next one in is going to be 8, got the here, next one in is going to be 16, next one is going to be 32, 32, the next one in is going to be 64, and the last one is going to be 128. Again, let's write down the binary number underneath and see what we actually have and what we're taking. So the 128 we're taking, the 64 we're taking, the 32 we're taking, the 2 we're taking, and the 1 we're taking. And if we add those all up, we will get 227.